Here, a 12 kilogram box sliding on a horizontal floor has an initial speed of 4 meters per second. The coefficient of friction is 0.2. The box moves a distance of 4 meters in 2 seconds. Then it asks, what the magnitude of the change of momentum of the box during this time is what? So we want to find the change of momentum. When the change of momentum is equal to the impulse, right? When you have a force acting on an object for a certain amount of time, that will cause a change of momentum. That's called the impulse. And impulse is basically just given by force times time. Okay. Time is already given. Time they tell you is 2 seconds. So we need to figure out what's the force, specifically the force in the x direction, because that's where the direction momentum is. So let's draw a free body diagram on the box. So you have a box here. You have gravity pointing down, mg. You have a normal force pointing up. And then against the motion, there is friction, right? So friction pointing to the left. So the only force in the x direction is the friction. That's the one that's going to change the momentum. Well, let's try to figure out friction. Friction is F equals coefficient of friction mu times N. What is normal force? Normal force in the y direction, normal force has to balance out the gravity, so normal force equals mg. So that's why we know the friction has to be mu times mg. Let's plug in the numbers. Mu is 0.2, m is 12, g we can use 10 meters per second. That gives us 24 newtons. Now let's plug into the change of momentum by the impulse, okay, the one in the top. So you see, force we already know is 24 newtons, but it's against the motion. It's actually negative 24 because it causes the momentum to decrease, and the time is 2 seconds. So negative 24 times 2 is negative 48 kilogram meters per second. So momentum decreased by this amount. Since they're asking about the magnitude, so we don't need to do the negative sign. So the answer should be B.